Okay, yeah, hi everyone. So this is uh yeah, we are happily inviting you for this new use cases for the system design series. So in this session we are going to discuss about how to build and design URL shortening service, which is like Bitly and some other URL shortening services. Okay. So yeah, so in this session we are going to discuss about um, generally it's a kind of like uh, generally this series is kind of helping you to build your improve your system design skills, and then how to approach what are the things, what are the concepts we have to keep in mind when you are going to design the new application, or when you are trying to improve the application performance or infrastructure. Okay, so like for example in this use case, so we are going to discuss about, as we discussed, we're going to discuss about like URL shortening service. So generally there are 3 to 4 when there is a point, when there is a time comes to design the system, we have to focus on 5 to 6 uh, components. We have to focus on that. So first one, what are the functional requirements, we have to do that. In the application basics, what are the functionalities it's going to provide to the users, so that is a functional requirement. And then what are the non-functional requirements we should look into it, which is like a scalability, low latency, and then applications would be highly available, and then applications would be very secure. So is there any trade-offs, so, is there exist, and then how we can rectify that. So these are the things comes under the non-functional requirements, and then we have to do some basic estimation based on our target audience. So generally, like based on that, we can set up our infrastructure and databases and storages and resources, everything we can allocate it. The basic assumption also we have to do it. We have to estimate it. The next will be like we have to start it from the database designs. What are the tables it's needed, and then each table what it's going to what are the data it's going to store it. And then like the next level would be like, and then we have to when it's a database design, we have to think about which kind of database we are going to use it, whether it's a, SQL database or no SQL database or graph databases, so or any other distributed databases we are going to use it to handle large scale of data. So the database decision also we have to take it. And then next step will be what are the APIs interfaces we want to develop it. So that's also we have to focus on that. And then once the API things, everything we decided, what each API, what is the type, and then what is the payload, or what is the expected response we want to get it. And then like once we finalize all the API, then we can move into the high level architecture. So generally, like high level architecture means like what are the components, what are the key components we are going to use it to create this system. Like how many servers are needed, what will be the interfaces, whether we need a API gateway, how we are going to deploy, which service we are going to deploy in our applications, whether it's a serverless or a computing service, are we going to use it anything, or what kind of like a storage service we are using it. And then like are we using any security services, are we going to follow it, or how our security principles and practices we are going to do it. Okay, and then what are the components which really help us to focus on the non-functional requirements also. Okay, and then how the architecture flow also, where how the request is going coming to our application, and then where it sends, and then each and then architecture flow of the each component. That's also we have to decide. Then finally we have to look into about what are the key issues, and then how we are going to solve that. So yeah, let's take this URL shortening service. So the functional requirements are users would be able to generate the short URL from the long URL. Okay, and then when user send the short URL, it should redirect it to the original website. Okay, and then user can create some custom URLs also. They can create that, and then user can there will be a separate dashboard Generally, when we are using Bitly or some other URL sorting service, that which is our dashboard, there we can set some expiration, or if we can delete, manage the URLs, we can manage it. And then user accounts and then authentication service also we have to provide it. And then what the rate limiting is one of the feature to prevent the abuse of, to prevent the resource utilization, to prevent the abuses by restricting the excessive requests. So it's one of the technique and then a procedure we are following it to avoid the DDoS attacks, and then controlling the resource usages. And the next non-functional requirement wise, like generally the scalability is main things. The user should, the service should handle millions of URL sorting and redirections, and then low latency. The URL redirections would be extremely fast and then highly available. The system, the service would be highly available, and then security wise, prevent abuse, the spamming and phishing, ensure the secure storage, the consistency and availability trade-offs, prioritize availability while ensuring the eventual consistency. So these are the non-functional things we have to focus on it. Okay. So what will be the estimation, like how many users going to use day to day in our applications? So we can, let's estimate that. So let's assume 100 million new sort URLs is going to be created per month. Okay, which means 3.3 millions per day. Okay, 10 is to 1 ratio, read write ratio is going to happen in our application. For every URL created, it accessed 10 times. Okay, 1 billion requests per month we can expect it. And then certain URL size 7 characters we can consider. And then what is the algorithm we are going to use? We are going to use base encoding. Generally base encoding, it will be base 62 encoding. So 62 power of 7, it can generate 3.5 trillion unique URLs, it can generate it. And then what is the data storage we are going to use it? The URL mapping, short URL with the long URL, we can assume 100 bytes per entry, we can assume that. And then 100 MP URLs per 100 million URLs per month, it cost it almost 10 GB per month we required. And then 1 year it will be 120 GB, and then 5 years we are expecting 600 GB of data storage we need that. So this is the basic estimation for our application at scale. Okay, so then next move to the database design side. So part in this part, like we need a URL databases is enough. So in this URL databases we have a short URLs and long URLs, and then like created at when it's created and when it's going to expire, and then which user is going to create it. So that these are the things we are going to store it. Okay, so this table is enough. And then to build the MVP products. Okay. And then what is the database we are going to use? Generally for a fast lookups, mostly read is going to happen a lot. So in that case, uh, better to use the AWS DynamoDB, so we can get the response in milliseconds. Okay, so that is it's a NoSQL database is preferred one to go for this URL sorting service. And then the API design wise, generally the major two APIs are needed. The first one, URL sorting API, where we have to pass the long URL in the payload. Okay, so then it will return the sort URL. It's going to return it. So the second one, we have to pass the certain URL in the API, and then it will return the long URL, and then it will redirect it to the original site. It will redirect it. So these are the two APIs we need that. And then high level architecture with the what are the like what are the AWS services it's going to help to build our high level architecture. Okay, so I'm choosing API gateway act as an interface for our incoming request to the users, and then Lambda to write our my business logics, like URL sortings and then redirection. All the logics will be written in Lambda, which is the serverless service. So handles the API request, URL sortings and redirection. DynamoDB key value store for sort and URL mapping, and then Elastic Catch. We can use it to catch the hot URLs and for faster redirects. And then CloudWatch, we can use it for monitoring API performance and errors. We can do it. So generally user request sort URLs and then API gateway, it will receive the message request, and then it will send it to the Lambda and then DynamoDB, and then user visits the API gateway and then Lambda. If it's catched, it will it will get the value from the catch, or it will send it back to the go and check the DynamoDB. Okay, so this is the basic like components we need that. And then when architecture diagram wise, so this is the basic architecture diagram, we can see it. So when user send the request, so for a API gateway based on the URL, it will redirect to the, it will trigger the specific Lambda. Okay, so if the request for sorting the URL, sorting Lambda will trigger, and then it will go and update the DynamoDB table, and then Elastic Cache as well, it will update it. And then if user hit user wants some redirection, if user give the request for redirecting it, then it will call the redirect Lambda, and then first it will go and check the Elastic Cache whether the sorting URL is available in the cache. If it exists, then it will get the value and then it will send it back. If it's not exist, then it will go and check the DynamoDB. Okay, this is the architecture diagram. So then now let's focus on what are the key issues, and then like what how generally we can solve it. To how to generate the unique sort URLs efficiently. So that is one of the problem, which means like we are, because we have to make sure each URL is going to receive some unique sort codes. So the sort codes, it won't get any duplicates. Is it won't get it. So what are the techniques we can follow it? Generally, base 62 encoding we can follow it. So it can have the characters like A to capital letters of A to Z, and then small letter of A to Z, and then 0 to 9. And then to generate compact unique IDs, it can generate it, and then maintain sequential counters in our DynamoDB auto incrementing key. We can follow it, and then we can follow use some hashing function, which is sort 256, to generate deterministic URLs. Also, we can follow it. Uh, we can use it. So sort 256, we can use it. And then handling high traffics and scaling, use Elastic Edge for hatching the hot URLs, reduce DB queries, and distribute the requests using AWS Global Accelerator to receive the, if you have a user base in very large regions, very wider region, then you can use AWS Global Accelerator, and then use DynamoDB on demand capacity for auto scaling. We can use it. And then preventing abuse and rate limiting, how we can use it. Generally, we can use AWS Web Application Firewall. We can use it to block some suspicious traffic, and then request we can generally block it. And then API gateway use, we can usage plans for rate limiting. Uh, for rate limiting, we can use API gateways plans. We can use it. And then for high availability, DynamoDB is multi availability zone replicated. And then CloudFront, we can use it for a global caching, for serving the static content. For example, if you have a dashboard, so for our user management or something, like for our URL management, if you have a dashboard, it's a static site, or a dynamic site is we have a front end, if it has some of the static contents, so we can use in CloudFront. It's a edge computing service, so that will load as fast as at the user location, user region, it will load it. So we can follow some active passive failovers with Route 53. That's also we can do that to ensure high availability. These are the key issues, and then the solutions we can follow it. So the next, I think that's it for this URL sorting service. The next would be, I have some I have developed some small applications that I can explain to you. So though this would be stop screen, sorry. Yeah, okay. I hope my screen is visible. Yeah. So I have developed the small applications, which is generally has two URLs and then rate limiting everything it has. Yeah, first one is shorten URL and second one is sort. Second one for redirect URL. Okay, let's execute the demo. Okay, so I have some APIs. So what it will do, it's a open APIs, so we can get some sample data. The post data as we can get it. So I'm passing this URL as a long URL as input to my shorten API. So I should receive some. Okay, I need to start the application first of all. Go run. Yeah, application is started. So here I received some shorten URL. You can see it, and then redirect URL I have. So here I can just paste that. Okay, when I execute it, so here you can see I just passed the URL. Okay, but it's redirecting and collecting the data from the actual website. So generally it's redirecting to it to the specific website. So these are the two APIs, and then I implemented rate limiting as well as catching also implemented in my Go applications. So here you can see the response times is literally reduced. So let's go and check the code. So I have used various Go packages. I used Gin for building the REST APIs, Go catch, which is an in-memory catch, and then rate package I used for rate limiting it, and then I have defined as various uh, static variables, which is URL catch and locking for a locking mechanism, lock, and then rate limiters, and then maximum request per second, how many requests it can handle. So, and then rate limited durations, I think per minute, I guess. So per minute, how many requests we can get it from a particular IP address. Okay. So like I have followed sort base 64 as well as SAR 256. I follow to create the shortening URLs. So let's go and check the shorten URL IP. Okay. So we are receiving long URL as a payload. Okay. So we are validating it, and then we are generating the sort URL based on the long URL. So we are calling generate sort URL function. We are converting into the SAR56 hash. We are creating it, and then we use first 6 bytes of hash to encode it. We are kind of using base 64 encode. Then and then we are returning the sort URL, and then we are using catch, and then we are locking that, so that will it will avoid multiple request accessing the catch at the same time. So we are storing sort URL and the long URL in the catch. If everything is done, then it will return the sort URL as a response. Okay, and then what we are doing it in the redirect APIs. So here we are receiving the certain code, certain URL from the params, and then we are checking it from the databases if it exists, and then we are getting the long URL, and then we are redirecting it. Okay, if it's not exist, then we are return the URL is not found. So that is how the application is generally running. So yeah, we set the rate limiter function. Here we have a logic for that. So we are collecting the client IPs. So we are setting the limiter like per minute how many requests the particular client IP can send it. So this is how the application is doing the rate limiters. So this is the sample applications built by using Golang. Yeah. So I think that's it about this URL shortening service. So we will in the next session, we will discuss about some other use cases. Yeah. Okay. Yeah. Thank you. Thanks, everyone.